Hi everyone, in this video we're going through Edexcel International GCSE May 2024 Mathematics B Paper 1R. Let's look at the first question. Question number 1. Write 75 millimeters as a fraction of 3 meters. Give your answer in its simplest form. So we need to write the fraction 75 millimeters over 3 meters. Since we want to simplify this, we need to make sure the units are the same. So 1 meter has 1000 millimeters. That means 3 meters would have 3000 millimeters. So it becomes 75 millimeters over 3000 millimeters. And now we can cancel the units because they're the same. We get 75 over 3000. Let's simplify this on the calculator. 75 over 3000, that gives us 1 over 40. 1 over 40, and that's the answer. Okay, question number 2. A, write 5.142557 to 3 decimal places. So we need to count from the decimal point. So 1 is the first decimal place, 4 second, 2 third, and we only need to write up until this point. So when we round it to 3 decimal places, we need to look at the next decimal place. Here it's 5. If it's greater than or equal to 5, we need to round the third decimal place up. So the number becomes 5.143 to 3 decimal places. The answer is 5.143. Okay, B. Write 6281 to 3 significant figures. So we have 4 digits here. The first digit is the first significant figure. Then we have the second significant figure, the third significant figure. We only need to show the first 3 significant figures. If we look at the next digit, it's less than 5, so we don't need to round the third significant figure. That means the number becomes 6280. 6280. Okay. Question number 3. Simplify this expression. We have numbers and letters together. So 8t to the power 7, v to the power 3 is in the numerator, 2t to the power 2 times v is in the denominator. So we'll deal with the numbers separately. 8 divided by 2 is equal to 4. What about t? So when we bring t to the power 2 to the top, that becomes t to the power minus 2. Therefore, it becomes t to the power 7 minus 2. Same thing with v. In the denominator, the power is v to the power 1. If we bring it to the top, to the numerator, it'll become v to the power minus 1. Therefore, v to the power 3 minus 1. So this becomes 4t to the power 5 times v to the power 2. That's the final answer. Okay, let's look at number 4. The nth term of a sequence is given by 7n squared plus 100. Find the 5th term of the sequence. So that means when n is equal to 5, what's the value of the term? So this becomes 7 times 5 to the power 2 plus 100. And what do we get? We will get 7 times 25 plus 100. And we can solve this with a calculator. That will be 275. 275. Next question. Barney says that 37 is a term in the sequence. Barney is wrong. Question B. Explain why Barney is wrong. So if we look at the formula 7n squared plus 100, n squared, the minimum value for n squared will be 0. It cannot be negative because no matter what number you put into n, whether it's negative or positive, the minimum value you can have is 0. The values can only be greater than 0. It cannot be less than 0. Therefore, the minimum value we can have for the entire formula is 100. If 7n squared becomes 0, the minimum value of the formula will become 100. So 37 is smaller than 100. That's why it cannot be a term in the sequence. So how do we explain? We can say the values in the sequence cannot be less than 100. That should be good enough. So we'll say the values in the sequence can not be less than 100. Okay. Okay, let's look at question number 5. Evaluate this. Give your answer in standard form. Okay, so let's get started. 6 times 10 to the power 9 plus 1.8 times 10 to the power 8 divided by 3 times 10 to the power 2. So in the numerator, we can add the two brackets if we have the same powers. So 10 to the power 9 and 10 to the power 8, one of them can be made the same as the other. So we can say 6 times 10 to the power 9 plus 0.18 times 10 to the power 9. So I intentionally decrease the value of 1.8 by 10 times, and I need to compensate by increasing the power by 10 to the power 1. That's why it goes from 10 to the power 8 to 10 to the power 9. So everything divided by 3 times 10 to the power 2. Now, in the numerator, both the brackets have the same power. So I can factor out the power, 10 to the power 9, and I can add the numbers. That becomes 6 plus 0.18 times 10 to the power 9 divided by 3 times 10 to the power 2. This is 6.18 times 10 to the power 9 divided by 3 times 10 to the power 2. And we can use a calculator. 6.18 divided by 3 gives me 2.06. And the powers, if I send 10 to the power 2 to the numerator, that becomes 10 to the power minus 2. That means it'll be times 10 to the power 9 minus 2, which is 2.06 times 10 to the power 7. That's the final answer. Okay, let's look at question 6. Simplify this. So we have numbers and letters inside the bracket: 36, a to the power 8, c to the power 2, an entire thing to the power 3 over 2. So we can do it step by step. We can apply the square root first within the bracket and apply the power 3 later. So 36 is a square number. If we apply the square root on 36, that becomes 6. If we apply the square root on a to the power 8, that becomes a to the power 8 over 2, which is 4. If we do the same for c squared, that becomes c. So now we don't have to the power half anymore. We only have to the power 3, the bracket to the power 3. From here, we can apply power 3 on all the terms. So 6 to the power 3, we can use a calculator, is 216. A to the power 4 to the power 3 is a to the power 4 times 3, and c to the power 3. So finally, this becomes 216, a to the power 12, c to the power 3. And that's the final answer. Okay, number 7. Without using a calculator and showing all your working, calculate this. Give your answer as a mixed number in its simplest form. So they've asked us to not use the calculator, meaning we have to show all the steps in our working. So we need to divide these two mixed numbers. Before we divide, it's best we convert them to improper fractions. So we have 2 1 by 4 divided by 2 1 over 7. So we need to convert these into improper fractions. So how do we convert? To get the numerator in the improper fraction, we need to multiply 2 and 4. 2 times 4 is 8. And then we'll add 8 with 1. So that is 9. 9. And the denominator will still be 4. 9 over 4 divided by the next one. To get the numerator, we'll have to multiply 2 and 7. That is 14. And we'll have to add 1 to it, which is 15. So the numerator is 15, the denominator is 7. The denominator stays the same. So what's next? We need to do the division. We can change the division sign to multiplication sign. And whenever we do that, the following fraction needs to be flipped. So this becomes 9 over 4 times 7 over 15. We need to take the reciprocal of the following fraction. Once we convert from division sign to multiplication sign. Now we can solve this. So 3 3s are 9, 3 5s are 15. There is nothing else to simplify. The numerator becomes 3 times 7, which is 21, divided by the denominator would be 4 times 5, 20. So 21 over 20. We still have an improper fraction. We need to convert this into a mixed fraction. How do we do that? We literally divide 21 with 20. So we can say 21s are 20. And if we subtract, we get 1. So how do we write the mixed number? So we can see that this is the remainder R. This is the quotient Q. And that's the divisor D. So the form of writing the mixed number is, you have to write the quotient first, then remainder over divisor. So according to this, our answer would be quotient 1, remainder 1 over divisor 20. The final answer is 1 over 20. Okay, question number 8. Given that y is equal to 12x cubed plus 16 over x squared, find dy by dx. So we need to differentiate this function. Before we differentiate, we need to change this in a form that is easy to differentiate. So y equals 12x cubed plus 16. We can move x squared to the top, x to the power minus 2. Then we can differentiate dy by dx is equal to, we'll move 3 to the front. 3 times 12 is 36. We need to subtract 1 from the power 3. So that becomes x squared plus, we need to move minus 2 to the front. So minus 2 times 16. And then we need to subtract 1 from the power, x to the power minus 3. So this becomes 36x squared plus, actually minus 32x to the power minus 3. Okay, and that's the final answer. And we don't need to change the form. We can just say the final answer is 36x squared minus 32x to the power minus 3. Okay, question number 9. X is equal to a over c minus f. A is 40 to the nearest whole number. C, F values are given as well. Calculate the upper bound for the value of x. Show you're working clearly. So we need to find the maximum value of x. To get the maximum value of x, we need to find the maximum value of the numerator, and we need to find the minimum value of the denominator. So let's have a look. A is equal to 40 to the nearest whole number, meaning A ranges from 39.5 to 40.5. C is equal to 2.2 to 1 decimal place, meaning it ranges from 2.15 to 2.25. F is equal to 0.6 to 1 decimal place, meaning it ranges from 0.55 to 0.65. These are upper bounds and lower bound values of A, C, and F. So we can say upper bound for x is equal to upper bound for A divided by, okay, now this one is a bit tricky. C minus F. We want the difference between C and F to be as small as possible, so that the denominator would be as small as possible. So there's one way to picture this. If I draw a number line, I can show 0.55 and 0.65 and 2.15. The upper bound of C is 2.25. So we can see that these two are values of F. These two are values of C. To find the difference between C and F, we need to subtract their values. So we want the smallest difference. So there are many different possible values of differences. This could be a possible difference between the two values. This could be another. This could be another. And this could be one as well. But if you compare all of them, the smallest difference we can have is when we use the upper bound of F and the lower bound of C. So that's what we're going to do. So when we take the c value, we will take the lower bound of c and subtract the upper bound of f. So that's equal to upper bound of a is 40.5 divided by lower bound of c. Lower bound of c is 2.15. And then upper bound of f is 0.65. 2.15 minus 0.65. And let's solve this on a calculator. So this gives us 27. And that's the answer. The upper bound for the value of x is 27. Okay, the next question is number 10. The region R shown shaded in the diagram is bounded by 3 straight lines. Find 3 inequalities that define region R. So let's start with the easiest one. So we can see a horizontal line where every point on the line has a y value of -1. No matter where you point, the y value is -1. Therefore, this line is known as y equals -1. So where's the region R? Is this region R above y equals -1 line, or is it below? It's above. If it's above, the first inequality that defines region R would be y greater than or equal to -1. We use greater than or equal to sign because the line is a solid line. If it was a dashed line, we would just say y greater than -1. Let's define the region using the other two lines. So we can see there's another line, x plus 2y equals 8. Now, if this equation was in the form of y equals mx plus c, it is easy to define the region. We can convert this equation into y equals mx plus c. This is one method. So we'll say x plus 2y is equal to 8. 2y is equal to minus x plus 8. Y is equal to minus half x plus 4. Once we have the equation in the form y equals mx plus c, we can just simply use the logic that if the region lies below the line, it will be y less than or equal to minus half x plus 4. If it's above the line, it'll be y greater than or equal to mx plus c. We can only do this for y equals mx plus c form. We cannot do it for other forms of linear equations. So we can say our second inequality is y less than or equal to minus half x plus 4. There's another way to define the region using the same line without changing the equation in the form y equals mx plus c. So what we do is we will write x plus 2y equals 8. And then we'll choose a point that lies in the region. And in this region, we can see the origin lies, and it is the easiest point to choose. So what we'll do is we'll just substitute the origin coordinates into this equation. So we can say at 0, 0, the equation becomes 0 plus 2, 0 equals 8. So what do we see is the left-hand side is 0, the right-hand side is 8. So it's not actually equal. It's actually less than or equal to. So therefore, the inequality would be x plus 2y less than or equal to 8. This is another way of defining the region with the same line. Okay, now we have this third line whose equation is not given to us. We need to figure out the equation ourselves. So we can use y equals mx plus c to figure it out. So this line has a y-intercept of 3. So c value is 3. In terms of gradient, we can choose another point that can easily be read. So this point, so let's say c is equal to 3 for this line. What is m? So m is equal to rise by run. So if I choose these 2 points, from here, how much does it rise to reach the next point? It rises 2 units. So rise is equal to 2. How much does it need to run to reach the second point? It only needs to run 1 unit. So 1. So the gradient is 2. M equals 2. Therefore, this equation is y equals 2x plus 3. And we can see the region lies below the line. It's not above the line, it's below the line. So we can just say the inequality that defines this region using this line is y less than or equal to 2x plus 3. These are the three inequalities. So let's write them down in the spaces provided. The first one is y greater than or equal to -1. The second one, there are two options. It's up to you. You can use y less than or equal to -half x plus 4, or you could also use x plus 2y less than or equal to 8. It's up to you. You just need to write one. Then the last one is y less than or equal to 2x plus 3. And that's it. Question 11. The diagram shows the point A and the point B. Question A, construct the locus of all points that are 4 centimeters from A. So we'll have to draw a circle around A, and the radius of the circle would be 4 centimeters. I'll be doing this on a different app. Let's have a look. So I have drawn point A and B on this sheet, and now I'm going to show how to draw locus of all the points that are 4 centimeters from A using a ruler and a compass. I'll fix my compass at point A. I need to set the arc radius to be 4 centimeters, so let's set it to 4 centimeters. So the pointy tip is on point A, and the radius is set to 4 centimeters now. So once I've set the radius, I need to draw a circle around this point for question A. So I'll draw a full circle around this point. And the radius of the circle is 4 centimeters. It means that all the points on this circle are 4 centimeters from point A. So we've answered the first question. Now let's look at question B. Using ruler and compasses and showing all your construction lines, construct the perpendicular bisector of AB. So to draw the perpendicular bisector of A and B, we'll place the needle tip at point A and the pencil tip on point B. So yes, the pencil tip is on point B, the needle tip is on point A. Once we have done this, we need to draw arcs above and below the line AB. So we haven't drawn the line AB yet. We don't need to draw because we haven't been instructed to, but let's draw the arcs. So we'll draw an arc above AB and another arc below AB. So this time we'll change the orientation. We'll place the needle tip at point B and we'll place the pencil tip at point A. And once we've done that, we will draw arcs again. We'll draw arcs again above and below. So there'll be an arc below, there'll be another arc above. Okay, let's get rid of this one. So we can see 4 construction arc lines. We just need to connect these two intersection points to get the perpendicular bisector. So we need to draw a straight line from this point to that point. And that's the perpendicular bisector of AB. Okay, just to make it clear, we should also draw the line from A to B so that we can see that we have drawn a perpendicular bisector of the line AB. Okay, let's look at the next question. So the region R consists of all the points that are nearer to B than to A and that are less than 4 centimeters from A. Question C, show by shading the region R. Label the region R. So we need to shade the region R. What is the region R? It says the region R consists of all the points that are nearer to B than A and that are less than 4 centimeters from A. So let's have a look at our drawing. So we need to shade the area that is closer to B. So since we have the perpendicular bisector, anything that is on this side of the perpendicular bisector is closer to B, but that's one condition. The other condition is that area needs to be within 4 centimeters from A. So we already have a locus of points that are 4 centimeters from A. So the region R should be this. So this is the region R that should be shaded. The area between the perpendicular bisector and the circle. We should label this region R. Okay. When you draw the perpendicular bisector, it's important to show these construction arc lines. Okay, question 12. We have a right triangle here. So it says, the diagram shows isosceles triangle ABC where AB is equal to AC. We can see, yes, these two sides, AB and AC, are equal to each other. Angle BAC is 90 degrees. And the side BC is 12.6 centimeters. Calculate the perimeter in centimeters to one decimal place of the triangle. So how do we find the lengths, the missing lengths, AB and AC? If length AB is x, length AC is also x, and we can use the Pythagoras theorem. We can say 12.6 squared is equal to x squared plus x squared. That means 2x squared is equal to 12.6 squared. X is equal to 12.6 squared divided by 2. And we have to square root all of this. 8.90, that is the value of x. Therefore, the perimeter would be 12.6 plus 8.90 plus 8.90. That gives us 30.4 centimeters. The reason I chose two decimal places for x is because x is just an intermediate value. We should always leave a decimal place extra for intermediate values so that the final answer could be rounded to one decimal place. Okay, number 13. The diagram shows the shape PTRQ, where PRQ is a triangle and PTR is a semicircle with diameter PR. We have a triangle and a semicircle. Angle PQR is 90 degrees. Angle PRQ is 40 degrees as shown. Side PQ is 8 centimeters. Calculate the total area in centimeters squared to the nearest whole number of the entire shape, PTRQ. So we can find the length of the missing sides in the triangle. So we can see that we have 40 degrees and 8 cm is opposite to it. To find QR, which is the adjacent side, we need to use opposite side and adjacent side, and that is going to be 10. So 10, 40 degrees is equal to opposite side 8 cm divided by QR. So QR will be equal to 8 over 10, 40. We can leave the value this way. We don't need to solve it yet. So we found QR, an expression for QR. We can do the same for PR. So PR is the hypotenuse. We can use the opposite side and hypotenuse, meaning, well, we can use the sine ratio. Sine 40 degrees is equal to opposite side 8 over hypotenuse PR. Therefore, PR is equal to 8 over sine 40. So we have an expression for PR and we have one for QR as well. To find the area of the triangle, we can use the formula of triangle. So we can say area triangle PQR is equal to half times base times height. And that's going to be half times the base is QR, which is 8 over 10, 40, times height is going to be 8. By the way, if we check the question again, they're asking us to find the total area to the nearest whole number. And area of triangle PQR is just an intermediate value. So I will leave my answer to one decimal place. So from the calculator, I'm going to write 38.1 centimeters squared. That's the area of triangle PQR. Now we need to calculate the area of the semicircle PTR. So the length PR is the diameter of the semicircle. So half of PR would be the radius. So half of PR will be the radius. If we know the radius, we can calculate the area of a circle and we can divide it by 2. So we can say area of semicircle PTR is equal to half times pi times r squared. Pi r squared is area of circle, so we divide it by 2. So this becomes half times pi times, in place of radius, we have to write PR divided by 2. So the value for PR is 8 over sine 4t. And we need to divide this by 2 to get the radius. So basically we can multiply by half, the bracket squared. So this gives us 60.8 cm squared. So the total area PTRQ would be equal to 38.1 plus 60.8. This gives us, which is equal to 98.9 centimeters squared, and this can be rounded to 99 cm squared. So the answer is 99 centimeters squared. Okay, question 14. Solve the simultaneous equations. We've been given 2 linear equations, and we need to solve them simultaneously. So we can either use substitution or elimination to solve this. So let's go with substitution. I don't see a clear elimination. In order to eliminate, we'll have to multiply both these equations by numbers. So let's just go with substitution. So I'll take the first equation. Let me call this equation 1, equation 2. So in equation 1, 2x plus 6y equals 14. I'll make x the subject of the equation, so x becomes 14 minus 6y, and all of this is divided by 2. So x becomes 7 minus 3y. Let me call this equation 3. So this is equation 3. And now I'll substitute equation 3 into 2. Substitute equation 3 into equation 2. And this gives me 3 times 7 minus 3y plus 5y equals 10. So I'll multiply 3 into the bracket. So 3 times 7 is 21 minus 3 times 3y is 9y plus 5y minus 10 is equal to 0. So minus 9y plus 5y is minus 4y. 21 minus 10 is 11 equal to 0. So we can move minus 4y to the other side. 4y equals 11. Therefore, y equals 11 over 4. So we found the value of y. Now we can use equation 3 to find the value of x from the value of y. So equation 3 is x equals 7 minus 3y. In place of y, we will substitute 11 over 4. So x equals 7 minus 33 over 4. We can just use our calculator to solve this. This gives me minus 5 over 4. So x equals minus 5 over 4, y equals 11 over 4. You can also write your final answer in decimals. So minus 5 over 4 is the same as minus 1.25. 11 over 4 is the same as 2.75. So both are fine. But you only need to write one form in your final answer, either the fraction or the decimal. Question 15. Make y the subject of this. So we can see we have y values in the numerator and the denominator. So we can square both sides, and this becomes c squared equals, on the right-hand side, if we square everything, the square root will be gone. So c squared equals 3y plus 5 divided by 8 minus y. So we can see there are 2 different y's. We need to make y the subject. So somehow we'll need to group them together. So I'll move 8 minus y to the other side. That becomes 8c squared minus c squared y equals 3y plus 5. I can see 2 terms that have y, and I'll bring them together. So 8c squared minus 5 is equal to 3y plus c squared y. On the right-hand side, I can factor out y, and we'll have 3 plus c squared. On the left-hand side, we have 8c squared minus 5. Now we can make y the subject of the equation. So y is equal to 8c squared minus 5 divided by 3 plus c squared, and that's the answer. 8c squared minus 5 divided by 3 plus c squared. Question 16. So the question is, A, D, B, and C are points on a circle center O. So we can see points A, B, D, C lying on the circle, and the circle has a center O. COD is the diameter of the circle. Yes, COD is the diameter. AB is the chord of a circle. So what is a chord? A chord is a line that cuts the circle at 2 points. So essentially, AB is a chord. CD is also a chord while being the diameter. So we have 2 chords intersecting within the circle, and we have been given the values of AP, PB, and PD. The question is, calculate the circumference in centimeters to 3 significant figures of the circle. So to calculate circumference, we can use the formula. Circumference is equal to pi times diameter. So do we know the diameter? We know the value of PD, 3 centimeters, but we don't know the value of CP. How long is CP? We don't know. If we can find CP, we can find the diameter. So how do we find CP? So we can use intersecting chords theorem. So if we have 2 chords intersecting within a circle, we can say CP times PD is equal to AP times PB. So we know 3 out of these. So CP times PD is 3 equals AP is 8 times PB is 4.5. So we can solve CP from here. CP is equal to 8 times 4.5 divided by 3. That gives us 12. So CP is equal to 12. All right, so the diameter becomes CP plus PD. Small d is equal to CP plus PD. CP is 12, PD is 3. So the diameter is 15 centimeters. Now we can calculate the circumference. Circumference of the circle is equal to pi times d, so 15 pi centimeters. But we need to show the answer in decimals to 3 significant figures. So we'll press 15 pi on our calculator. 15 pi gives me 47.12. 47.12 centimeters. So I have written the 4 significant figure value from the calculator, and then I'll round this to 3 significant figures. So this becomes 47.1 centimeters. Question 17. So we've been given 2 vectors OA and BA. Question A, find the position vector of the point B. So we need to find vector OB. How do we find it? So if we look at vector BA, we can say vector BA is the same as OA minus OB. Just like if we have, for example, if we have vector PQ, we can say this is equal to vector OQ minus OP. If we have vector ST, we can say it's equal to vector OT minus OS, just like that. So BA is equal to OA minus OB. All right, so we'll make OB the subject of the equation. So vector OB is equal to OA minus BA, and this is equal to 3 minus 2, subtract 5 minus 9. So this becomes 3 minus 5 is minus 2. Minus 2 minus minus 9 is equal to minus 2 plus 9, which is 7. So the answer for position vector of point B is minus 2, 7. Question B, calculate the magnitude, the absolute value of vector OB, giving your answer as a surd. So vector OB is equal to minus 2, 7. The modulus of vector OB would be square root of minus 2 the whole squared plus 7 squared. And this gives us square root of 4 plus 49, and that is square root of 53. Can we simplify this any further? I just checked with the calculator. We can't. And because 53 is a prime number. So the answer is square root of 53. Okay, question 18. The table gives information about the heights in centimeters of 80 plants in a garden. So if we add up all the frequency, we'll get 80. Question A, find the class interval that contains the median height of these plants. Since 80 is an even number, we will divide 80 by 2. We get 40. That means there are two middle numbers. One is the 40th value. The next is the 41st value. 40th value and the 41st values are two middle numbers, and we need to find where they are. In which class do they lie? As we go down the table, the value of height increases. So everything is arranged in ascending order. We just need to count where the 40th value and 41st values are. So at the end of this row, we have the second value. At the end of this row, we need to add 26 more values. So 26 plus 2 is 28 values. The 28th value lies in the second row. If we add 10 more values using the third row, we'll have the 38th value as the final value in the third row. And then we can see that if we add the next row, 38 plus 24 gives me 62. So 62nd value is the last value in the fourth row. But 39th value is the first value in the fourth row. So both my 40th and 41st values lie within this class. So the class interval that contains the median height is 30 less than h less than or equal to 40. So 30 less than h less than or equal to 40. This class contains the median height of these plants. Question B, calculate an estimate for the mean height in centimeters of these plants. So we can say the mean height, to get the mean height, we need the sum of frequency times x divided by sum of frequency. We'll need the midpoints of height values for each row. So we can create a column for x, the midpoint x. The midpoint for 0 to 10 would be 5. Midpoint for 10 to 20 would be 15, 25, 35, and 45. We can solve the sum of f times x. We can also create a column for f times x. We can calculate 2 times 5 is 10, 26 times 15 is 390, 10 times 25 is 250, 35 times 24 gives us 840, and 18 times 45 gives us 810. So we can sum up all of this, and that'll be sum of fx, and we already have sum of f. So sum of fx would be 10 plus 390 plus 250 plus 840 plus 810. And sum of frequency is the total number of plants, which is 80. And this gives us 115 over 4, which is 28.75 centimeters. And that's the estimate of the mean height of these plants, 28.75. Okay, number 19. The students in class 7T and the students in class 8Y were asked to name their favorite ice cream flavor. The table shows information about the favorite ice cream flavor for class 7T, and the pie chart shows information about the favorite ice cream flavor for class 8Y. So the table is for class 7T, the pie chart is for class 8Y. There are 32 students in 7T, and there are 45 students in class 8Y. More students in class 7T than in class 8Y said vanilla was their favorite ice cream flavor. We need to find how many more students from 7T said that vanilla was their favorite ice cream flavor. We need to calculate the number of students who like vanilla in 7T and the number of students who like vanilla in 8Y. So since we know the total number of students in 7T, we can say 32 is equal to 3x plus 1 plus 5x minus 12 plus 2x plus 3. If we group all the x terms together, 3x, 5x, and 2x, if we add them, we get 10x. And if we add all the numbers together on right-hand side, that is 1, minus 12, and 3. So basically 4 minus 12, which is minus 8. So 32 is equal to 10x minus 8. That means 10x is equal to 32 plus 8, 40. X is equal to 4. So we can find the number of students who like vanilla in 7T. So vanilla in 7T, number of students would be 3 times 4 plus 1, which is 13. 13 students like vanilla in class 7T. Now let's find the number of students who like vanilla in 8T. So 80 degrees out of 360 degrees represent number of students who like vanilla in 8y. So we can say number of students who like vanilla in 8y is equal to 80 degrees out of 360 degrees times the total number of students is 45. So this gives us 8 over 36 times 45, 10. 10 students like vanilla in class 8y. So how many more students from 7T like vanilla than 8y? 3. So 13 minus 10 is equal to 3. 3 more students in 7T like vanilla. Okay, question 20a. Solve this equation. Show clear algebraic working. So 7 plus 3y over 2 plus 5 is equal to 4y minus 7. We need to group y's together. So let's do this step by step. So let's move plus 5 to the other side. So 7 plus 3y over 2 is equal to 4y. Minus 7 minus 5 is minus 12. And then we can move the denominator 2 to the other side, which will multiply. So 7 plus 3y is equal to 2 times 4y is 8y. 2 times minus 12 is minus 24. Then we can group all the y terms together. So 7 plus 24 is equal to 8y minus 3y, which is 5y. So 5y is equal to 31. Y is equal to 31 over 5. We can show the decimal answer. 31 over 5 gives us 6.2. Y is equal to 6.2. Okay. Question B, we have an equation a is equal to 8x minus 2w. We need to work out the value of x when a is equal to minus 35 and w is equal to minus 4.5. So a equals 8x minus 2w. We can make 8x the subject. 8x is equal to a plus 2w, and then x is equal to 1 over 8, a plus 2w. And we can substitute the values of a and w to get the value of x. So x is equal to 1 over 8. The value of a is minus 35 plus 2 times minus 4.5. It's important to use brackets to not make mistakes with negative signs. So if we put all of this on our calculator, we get minus 11 over 2. The decimal answer would be minus 5.5. That's it. Okay, question 21. The diagram shows a solid shape made by joining a large hemisphere and a small hemisphere. We can see the two hemispheres here. The center of the base of the large hemisphere and the center of the base of the small hemisphere meet at the point O. Yes, we can see that. The centers of the bases, they're meeting at point O for both the hemispheres. Radius of large hemisphere is to radius of small hemisphere is equal to 3:1. If we say that the radius of the small hemisphere is r, the radius of the large hemisphere would be 3r, because it's 3 times larger than the radius of the smaller hemisphere. So this radius would be r, and this radius, the large hemisphere, would be 3r. The total surface area of the solid shape is 567 pi centimeter squared. The question is, calculate the total volume in centimeter cubed to 3 significant figures of the solid shape. So we need to calculate the total volume. To calculate the total volume, we need to calculate what r is. How do we calculate r? We need to use this total surface area value to calculate r. Once we get r, we can calculate the volume. Let's form an equation for the total surface area. So we can say total surface area is equal to 567 pi. Let's think about what forms total surface area. So it has the curved surface area of the bigger hemisphere. Surface area of a sphere is 4 pi r squared. So the curved surface area of a hemisphere would be half of this. It'll be 4 pi r squared over 2, meaning it'll be 2 pi r squared. Since we're looking at the larger hemisphere, the radius of the larger hemisphere is 3r. So the curved surface area would be equal to 2 pi. In place of r, we'll have to write 3r the whole squared. Let's write that down. 2 pi bracket 3r the whole squared. So that's the curved surface area of the larger hemisphere. Plus, we need to do the same for the smaller hemisphere. So the curved surface area of the smaller hemisphere is 2 pi r squared. The radius is just r for the smaller hemisphere. What else do we have? We also have this surface area that is the base of the larger hemisphere that is exposed to the outside. We need to include this as well. So how do we account for this? So that is a circular area, pi times 3r the whole squared. And we need to subtract the smaller circle from that, which is pi r squared. So if we add the curved surface area of the larger hemisphere, curved surface area of the smaller hemisphere, and this base area that is exposed to the outside, we will get the total surface area. So let's write those down. 2 pi r squared plus pi times 3r the whole squared minus pi r squared is equal to 567 pi. Let's continue solving this. So since we can see pi in all of the terms, we can cancel the pi. If we expand 3r squared, that becomes 9r squared, and 9r squared times 2 is 18r squared, plus 2r squared, plus 3r the whole squared would be 9r squared, minus r squared is equal to 567. Now because on the left-hand side, all the terms are r squared terms. That means we can add all of these terms together. So 18 plus 2 is 20, 20 plus 9 is 29, 29 minus 1 is 28. So 28r squared is equal to 567. That means we can find the radius. R is equal to 567 divided by 28, and we'll have to square root this. We're not going to add plus or minus sign here because we cannot have a negative value for radius. So we don't need plus or minus sign here. So r is equal to, let's put this on our calculator. This gives us 9 over 2. 9 over 2, or you can say this is 4.5. So what is r? R is the radius of the smaller hemisphere. So we should also find what 3r is. So 3r would be 3 times 9 over 2, which is 27 over 2, 13.5. So the radius of the larger hemisphere is 13.5, smaller hemisphere is 4.5. We still need to calculate the volume, calculate the total volume, and we need to express our answer in decimals to 3 significant figures. So let's think about the volume formula. So volume of a sphere is 4 over 3 pi r cubed. Volume of a hemisphere would be half of this, which would be, so half of this means that's 2 over 3 pi r cubed. So since we're calculating the volume, we just need to add the volume of the larger hemisphere to the volume of the smaller hemisphere. So let's do that. The volume formula is 2 by 3 pi r cubed for the hemisphere. Total volume is equal to 2 over 3 pi. The volume of the larger hemisphere has a radius of 3r. So we don't need to write 3r anymore. We can just put the value that we obtained for 3r. So 2 over 3 pi 13.5 cubed plus, we'll do the same for the smaller hemisphere, 2 over 3 pi, the radius of the smaller hemisphere, which is 4.5 cubed. This gives us an answer of 1701 pi cm cubed, but we need a decimal answer correct to 3 significant figures. So we'll change this to decimal, 5343 cm cubed. This is 4 significant figures, and we'll round this to 3 significant figures. The fourth significant figure is less than 5, so we don't need to round the third significant figure up. It'll just be 5340 cm cubed. That's a total volume. 5340. Okay. Question 22. A. Express root 50 plus root 242 in the form a root a, where a is an integer. So we need to simplify these. Root 50 plus root 242. We are free to use our calculator. So root 50 gives us 5 root 2 plus root 242 gives us 11 root 2. So we can see root 2 is common in both the terms, so we can factor out root 2. So root 2 bracket 5 plus 11, and that is 16 root 2. Okay, so 16 root 2 is not the same as a root a. We need both these numbers to be the same, so we'll have to manipulate this. So let's try breaking 16 down into 8 times 2 times root 2. And then we can see that 2 can be written as root 4. So let's change that. 8 times root 4 times root 2. Root 4 times root 2 will give us root 8. So finally we have 8 root 8, and that's the answer. Let's look at B. Question B. Express 12 over root 5 minus 1 in the form y root x plus y, where x and y are integers. Show each stage of your working. So let's start with 12 over root 5 minus 1. So we'll have to rationalize the denominator. How do we do that? We will need to multiply both top and bottom by root 5 plus 1, 5 plus 1. And let's see what we get. So if we multiply the numerator, we'll get 12 root 5 plus 12. If we multiply the denominator, we'll get, okay, root 5 times root 5 gives us 5. Since this is going to be a difference of squares, we don't need to think about the middle terms. For example, if we multiply a minus b with a plus b, we will get a squared plus ab minus ab minus b squared. And you can see the middle terms are cancelled, a squared minus b squared. Similarly, we don't need to think about the middle terms when we multiply these two. So root 5 times root 5 gives us 5. Minus 1 times 1 gives us minus 1. The middle terms will be cancelled. That's why I'm not solving middle terms. Okay, so what happens? So we have 12 root 5 plus 12 divided by 4. And then if we divide both the terms on the numerator by 4, we'll get 3 root 5 plus 3. And this is the form they want, y root x plus y. So 3 and 3 are the same on both the terms. Okay, so the final answer is 3 root 5 plus 3. Let's look at question 23. X plus 4 is a factor of this cubic expression. We have an unknown k here, kx squared, where k is a constant. Question A, use the factor theorem to show that k is equal to 19. The function f of x is equal to 6x cubed plus kx squared minus 26x minus 24. Since x plus 4 is a factor of this function, when we substitute minus 4 in place of x, that should give us 0. Meaning, if we find f of minus 4, that should be equal to 0, according to the factor theorem. We'll substitute minus 4 in place of x, and that should be equal to 0. So that becomes 6 times minus 4 cubed plus k times minus 4 squared minus 26 times minus 4 minus 24 should be equal to 0. 6 times minus 4 cubed gives us minus 384 plus minus 4 squared would be 16k. Minus 26 times minus 4 gives us plus 104 minus 24 equal to 0. And then let's add up all the numbers. Minus 384 plus 104 minus 24 gives us minus 304. So 16k minus 304 is equal to 0. That means k is equal to 304 divided by 16, which is 304 divided by 16 is equal to 19. Yes, and we've shown that k is equal to 19. Question B, hence solve this cubic equation and show clear algebraic working. Okay, so we've seen in question A that x plus 4 is a factor of this. If we divide, we will get a quadratic factor. So let's find that quadratic factor first before we solve the equation. So we'll do the long division of this cubic expression. 6x cubed plus 19x squared minus 26x minus 24 will be divided by x plus 4. What do we need to multiply x with? To get 6x cubed, we'll need to multiply with 6x squared. So x times 6x squared is 6x cubed. We'll also have to multiply plus 4 with the same. So 4 times 6x squared is 24x squared. And we'll subtract. This will give us 0 here. 19x squared minus 24x squared is minus 5x squared. We'll bring the next term down, which is minus 26x. So for this, we need to multiply x with minus 5x to get minus 5x squared. Okay, we'll have to multiply 4 with minus 5x as well. That gives us minus 20x. And if we subtract, we get 0 for the first one, minus 26x plus 20x, which is minus 6x. And then we'll have to bring the next term down, which is minus 24, and multiply again. So x times minus 6 will give us minus 6x. And we'll have to multiply plus 4 with minus 6, which gives us minus 24. And this time, everything is cancelled and we get 0. The remainder is 0. So that means that 6x cubed plus 19x squared minus 26x minus 24 is equal to 0 can be written as x plus 4 times 6x squared minus 5x minus 6 equal to 0. In order to solve this completely, we need to factorize the quadratic factor further. So 6x squared minus 5x minus 6 can be factorized into 2 brackets. Let's do trial and error. So we have minus 6 as the last term. So we need to think of 2 factors of minus 6. So let's try minus 3 and plus 2. So minus 3 plus 2. If we multiply minus 3 with plus 2, we get minus 6. Okay, so the last term is confirmed. For now, let's check what we need to put in these positions to get the quadratic. We need to think about the factors of 6x squared. The factors of 6x squared could be 3x, plus 3x, and plus 2x. Let's try putting 2x there and 3x over here. This means 3x times 2x does give us 6x squared, meaning the last term is correct, the first term is correct, but do we get the middle term? Do we get the minus 5x? So to get the middle term, we multiply minus 3 with 2x, which gives us minus 6x. And we also need to multiply 3x with plus 2, which gives us plus 6x. And if we solve these two, we end up getting 0x, which is not the case. We need to get minus 5x somehow. So this doesn't work. We need to change. Maybe we can try swapping the positions. We can try placing 2x here and 3x there. So again, 2x times 3x gives us 6x squared, but let's check the middle terms. Minus 3 times 3x gives us minus 9x. 2x times 2 gives us 4x. And yes, this is equal to minus 5x. So this fits the quadratic equation. So we can say, therefore, x plus 4, 1 bracket, 2x minus 3, second bracket, 3x plus 2, third bracket, is equal to 0. This gives us 3 different values of x. X equals minus 4, x equals 3 over 2, and x equals minus 2 over 3. These are our answers. Okay, let's look at question 24. There are only pink and yellow sweets in a bag containing n number of sweets. There are 25 more pink sweets than yellow sweets. So let's say number of yellow sweets is y. So y is equal to yellow sweets. And let's say p is equal to a number of pink sweets. And we can form equations. We can say p is equal to y plus 25. If number of yellow sweets is y, number of pink sweets in terms of y would be y plus 25. And the total number of sweets is n. That would become y plus p. Total number of sweets is number of yellow sweets plus number of pink sweets. If we want to write number of pink sweets in terms of y, this becomes y plus 25. So the total number of sweets would be 2y plus 25. That's the expression for the total number of sweets, 2y plus 25. So the next sentence says, Stan takes at random 2 sweets from the bag. So Stan takes 2 sweets from the bag. The probability that Stan takes 2 pink sweets from the bag is 7 over 19. Find the probability that Stan takes 2 yellow sweets from the bag. Show clear algebraic working. So we need to work out the probability first. Let's figure out the probability of picking 1 pink sweet from the bag. So probability of pink, number of pink sweets divided by total number of sweets. So number of pink sweets in terms of y is y plus 25. We will have to divide this by the total number of sweets, which is 2y plus 25. Because probability is equal to number of desired outcomes, which is the numerator, number of pink sweets, divided by the total number of outcomes, which is the total number of sweets, 2y plus 25. That's the probability of picking 1 pink sweet, but probability of picking 2 pink sweets in a row would be, so we pick pink sweets for the first time, y plus 25 over 2y plus 25, and then another time, this time it'll be y plus 25 minus 1, because there'll be 1 sweet less, and then the total will also be 1 sweet less. So 2y plus 25 minus 1. Because if 1 sweet has already been picked, we are not replacing it, which means that 1 less pink sweet in the bag. So this becomes y plus 25 over 2y plus 25 times y plus 24 over 2y plus 24. So we'll have to multiply these. The numerator would become y squared plus 25y plus 24y plus 24 times 25. 25 times 24 gives us 600, divided by 2y times 2y is 4y squared. 2y times 24 is 48y. 25 times 2y is 50y. 25 times 24 is 600 again. And this is equal to 7 over 19, the probability that has been given to us. We'll solve this equation from here. So we can cross multiply. We can say 19 times, the numerator is y squared plus 49y plus 600 equals to 7 times 4y squared plus 98y plus 600. Let's continue solving this. So we'll multiply 19 into the bracket. 19y squared plus 931y plus 11400. We'll multiply 7 into the bracket. 7 times 4, 28y squared plus 686y plus 7 times 600 would be 4200. We'll need to bring all the terms on one side. So 28 minus 19 would be 9y squared. 686 minus 931 would be minus 245y. 4200 minus 11400 gives us minus 7200. And that will be equal to 0. And we'll need to solve this. So to solve this, we can use our calculator. Some of the calculators allow us to solve these quadratic equations. If not, we can use the quadratic formula. We can also use simple factorization, but let's use quadratic formula for simplicity. So we can say y equals minus b plus or minus square root of b squared minus 4ac over 2a, and minus b would become 245 plus or minus square root of minus 245 squared is the same as 245 squared, minus 4 times a is 9 times minus 7200, that is c, divided by 2a, which is 18. This gives us 45, y equals 45, or y equals minus 160 over 9. So what is y? According to what we defined, y is the number of yellow sweets in the bag. So that cannot be negative, so we'll reject the negative answer. So this answer is rejected. So that means the number of yellow sweets is 45. We still need to answer the final question. Find the probability that Stan takes 2 yellow sweets from the bag. Okay, so we know the number of yellow sweets in the bag, which is 45. We also need to know the total number of sweets in the bag, that is 2y plus 25. So let's find that. So the total number of sweets would be 2 times 45 plus 25, and this equals 90 plus 25, 115 sweets altogether. So again, the probability that Stan takes 2 yellow sweets from the bag would be, so to start with, we have 45 yellow sweets out of 115, but if he has picked 1 yellow sweet already, there will be 1 less yellow sweet next time, so 44, and there'll be 1 less sweet overall, 114. And if you multiply this, we'll get the answer. 45 times 44 divided by 115 times 114, this gives us 66 over 437. That should be the answer. And since we're not told to convert this into a decimal or any significant figures, we can leave this as our final answer, 66 over 437. Okay, question 25. Let's read the question. The diagram represents a small horizontal field ABCD. So this is a quadrilateral 4-sided polygon. Side AB is 8 meters, BC is 11 meters, CD is 15 meters, angle ABC is 115, angle ADC is 53 degrees. Calculate in meters squared to the nearest whole number the area of the field. We can divide this quadrilateral into 2 separate triangles. Let's have a look. What if we divide the quadrilateral into 2 separate triangles this way? And from here, we can use half AB sine C to calculate the area of this triangle. Once we have the area of this one, we can find the area of the other. But to use half AB sine C, we would need to know this side, AD. And to find AD, we would need to know side AC. We can use cosine rule to find the side AC using the first triangle. So let's try this way. So let's start by finding the area of triangle ABC. So area triangle ABC is equal to half AB sine C. That's a formula. Half times the 2 adjacent sides here are 8 meters times 11 meters times sine the angle 115 degrees. Since the final answer needs to be rounded to the nearest whole number, we will keep this answer to first decimal place. So this gives us 39 39.8 meters squared. So we haven't rounded this answer yet. That's area of triangle ABC. We need to find the area of triangle ACD. To do that, we need to find the side AD. And to do that, we need to find the side AC. We'll use the first triangle, ABC, to calculate AC using cosine rule. So the opposite side, AC squared, is equal to the sum of the squares of adjacent side, 8 squared plus 11 squared, minus 2 times the product of adjacent sides, 8 times 11 times cos the angle, which is 115 degrees. That's the cosine rule. AC squared is equal to 259.38. So AC would be equal to square root of 259.38. So we have the answer for AC. Now we need to find the value of AD. So to find AD, we'll use cosine rule again. Opposite side is AC. One of the adjacent sides is AD. So we'll use cosine rule again. AC squared is equal to, so instead of saying AC squared, we can say 259.38 is equal to the sum of squares of two adjacent sides. So AD squared plus the other adjacent side is 15. 15 squared minus 2 times the product of two adjacent sides, AD times 15 times cos the angle, which is 53 degrees. Cos 53. So we'll have to find AD from here. So 259.38 equals AD squared. 15 squared is equal to 225. And then we need to multiply 215 and cos 53, 18.05. So minus 18.05 AD. So let's move all the terms on one side. So that becomes AD squared minus 18.05 AD. And then the next one would be 225 minus 259.38. This gives us minus 34.38 equal to 0. This is a quadratic equation, and we can solve this using the quadratic formula. We can say AD is equal to minus b plus or minus square root of b squared minus 4ac over 2a. And we'll substitute values. B value is minus 18.05. So this becomes 18.05 minus cancels. Plus or minus square root of 18.05 squared. We don't need to put the minus sign because when we apply the square, the minus sign cancels. Minus 4 times a value is 1. C value is minus 34.38 divided by 2. And let's solve this. This gives me 19.78. That's the length of AD. Finally, we can use half AB sine C to calculate the area of triangle ACD. So area of triangle ACD, we can use half AB sine C. So half. So one of the adjacent sides is 19.78. The other adjacent side is 15 times sine. The angle is 53. Yes, the angle is 53. Sine 53. And this gives us 118.4 meters squared. So we can say the total area is equal to area of triangle ABC, which is 39.8 meters squared, 39.8 plus area of triangle ACD, 118.4. And this gives us 158.2 meters squared. And we'll need to round this to the nearest whole number, which is 158 meters squared. So final answer is 158. Okay. The last question, question 26, show that all of this can be written in the form P over X plus Q, where P and Q are integers to be found. So we need to simplify this. So 6 over X minus 2 plus 4 over x plus 3 times 5x squared minus 15x plus 10 over x squared minus 1. First of all, within the brackets, we need to make sure the denominators are common. We will multiply the first fraction with x plus 3 top and bottom. So 6 times x plus 3, which is basically 6x plus 18. The common denominator would be x minus 2 times x plus 3. And the numerator of the second fraction would be 4 times x minus 2, which is 4x minus 8. So that's the fraction within the brackets times. We can try factorizing the numerator. We can factorize 5 out of the numerator, and that becomes 5 bracket x squared minus 3x plus 2 divided by x squared minus 1. The numerator on the first fraction would simplify to 10x plus 10 divided by x minus 2 times x plus 3 times. We can factorize the numerator on the second fraction. So we can try the factors of 2. Since it is plus 2, the two factors could either be plus 2 plus 1, or they have to be minus 2 minus 1. And since the middle term is minus 3, we should go with minus 2 minus 1. And the factors of x squared can just be x and x. And let's try expanding this again. So x times x is equal to x squared, minus 2 times x is equal to minus 2x, minus 1 times x is equal to minus x, minus 2 times minus 1 is equal to plus 2. And yes, we factorized it correctly. We're getting the expanded form back. So this is the correct factorization. Okay, that's the numerator on the second fraction. The denominator would be x squared minus 1. To make things simpler, we can actually convert x squared minus 1 into two brackets. It can be converted into x plus 1 times x minus 1. The reason we're factorizing everything is to see if we can cancel the brackets as much as we can. Okay, so one more step. We will factorize the 10 in the numerator of the first fraction. So 10 times x plus 1 times 5 times x minus 2 times x minus 1 divided by x minus 2, x plus 3, x plus 1, x minus 1. So we can cancel a few brackets. So x minus 1, x minus 1. Everything is multiplied and divided, so we're free to cancel the brackets. We can cancel x plus 1, x plus 1. We can cancel x minus 2, x minus 2 there. So at the end, we have 10 times 5, which is 50 in the numerator, divided by x plus 3 in the denominator. And this is the form that they want, p over x plus q. So p here is equal to 50, and q is equal to 3. And that's our final answer, 50 over x plus 3. And this is the end of May 2024, paper 1R for Maths B.